This video is going to look at production possibilities frontier general equilibrium model. Before we get into this, I want to say a few words on what we mean by a general equilibrium model versus a partial equilibrium model. A partial equilibrium model is like supply and demand. In that model, we're looking at one market in isolation. So in other words, we're looking like how is it that the market for instance, bread might equilibrate itself. So you think of like everybody who might want to buy bread, they get represented on the demand side. Everybody who might want to sell bread, or make and sell bread, gets represented on the supply side of the market. And then how does the price adjust to bring that market into equilibrium? What we're sort of assuming is that the rest of the economy is in equilibrium, or we're not looking at the rest of the economy. So we're looking at one market in isolation and saying how does that market go about equilibrating itself. In a general equilibrium model, what we were saying is that we'll have a very simple model of the economy. So we'll be modeling a very simple economy, but the idea is that we're going to consider equilibrium being determined in all of the markets in this simple model economy simultaneously. So how is it that we can, building in the fact that there could be interplays between the markets for fruit and bread, or if you want to think about the market between hamburger and steak. And so when you think of these connections between markets, general equilibrium will be a way to model this where all of those connections are included. A general equilibrium model in some ways is very important from a standpoint of making sure that we understand how the market, the economy as a whole, can be operating. Probably for the purposes of illustrating how it is that we think markets work, in most cases, partial equilibrium models are fine. But it is important that we have that we have a capacity to think about market, how we would create a model in which multiple markets, all of the relevant markets, can clear at the same time. So that's what we're going about here. Now this is a production possibilities frontier. It's probably the very first graph you see in economics. We cover this before we go into supply and demand. And the production possibilities frontier, we would say like, okay, this would represent in an economy, in this case I just consider the goods to be bread and fruit. In our simple economy where we have two goods that consumers are going to want to consume, given all of the resources that we have and given all of the technology that we have, and then you might also say the institutions that are in place to maybe allow firms to form and where they have property rights to allow investment and capital and so forth. But given resources, technology, and institutions, these are the options. These are the different combinations of bread and fruit that we could produce. Well, we're going to tell a story here in which we can say that this production possibilities frontier itself is actually like the supply curve in this model, in this general equilibrium model. And then what we'll do is we're going to add in here an indifference curve. Because remember, indifference curves represent consumers' choices over two different goods. And so here we have two consumption goods, two goods that consumers might be choosing to consume in this economy, bread and fruit. So we've got the right types of variables on the axes that we could legitimately draw an indifference curve in this case. So if we want to think about this, there would be a whole family, and we'll assume sort of normal shaped indifference curves. We have a whole family of indifference curves in here. And one way to think about this, the way I probably suggest to think about this, is think of this as like a representative or sort of average consumer. So we're going to assume that there's lots of consumers out there in the economy. Let's just sort of say like this is an average consumer. If everybody was identical, that would be really easy as a way to think of it. Well, everybody would have the exact same preferences. But we don't really have that. We don't want to get into any more detail to say like, well, how would you be aggregating these different preferences? Let's just say we sort of have an average or representative consumer, and they have some indifference curves here. We'll draw just normally shaped. Now, when we introduced the production possibilities frontier, we used that as a way to distinguish between what's feasible in the economy and what's infeasible. And then once we talk about feasibility, what will be efficient and what will be inefficient. Now, with just the production possibilities frontier, we were able to say, like, obviously everything that was on the frontier or inside would be efficient. And then we said, well, everything that's on the frontier would be efficient. Any point that would be inside of the frontier would be inefficient. And in that case, we introduce it. I know I always like to say, well, if we don't want to make any kind of assumptions in an economy about like how much, whether people like fruit or bread, then we can't go any farther than that. We can't go any farther than to say like, well, any point that's on the frontier could be efficient is efficient in the sense that we can't pick out any one point on the frontier as being better than the others until or unless we get some preferences in here. Well, now that we know what indifference curves are, now we can actually throw in indifference curves up here and have preferences, and that's what we have here. So given that we have preferences, we can actually refine what we would say before about efficiency. Efficiency would be not just any point on this frontier. We can now identify one point that would actually be the best. And the way to think about this is imagine from the efficiency standpoint, imagine you're trying to maximize utility. Back when we were in chapter 3, you're trying to maximize utility. You have indifference curves here, and you're trying to say, well, what's the highest utility indifference curve? Well, I guess I should have played with here. So you know that these are indifference curves representing different levels of utility. What's the highest level of utility that this average or representative consumer can get on and can achieve, given that they have to be somewhere on or inside of the PPF? Well, we know they're not going to want to be inside the PPF because any point that's on the PPF has to be better than points that are, well, points inside the frontier are dominated by points that are on the frontier. But given that we now have some preferences, that we specify preferences for the representative consumer, we can actually pick the tangency point. The tangency point here would be the efficient point in the economy. So we could label this E, and this is efficient. So and then again would be at the tangency between the indifference curve and the PPF. And that would give us that the efficient quantity of fruit in this economy would be F1, and the efficient quantity of bread would be B1. So this is the efficient point in this economy, given that we've added preferences, and we can now once we have preferences, we can say like, oh yeah, well in this economy, people wouldn't want to be up here. If the economy was operating up here, this wouldn't be efficient because consumers would prefer to be over toward E or actually at E than at a point up here where they have lots of bread and no fruit. Okay. So this is efficiency in our general equilibrium model. The other thing we need to think about is equilibrium. And to get equilibrium in here, what we're going to do is put a budget line. And in this model, it turns out we don't really have money. If you want to think about that we have money, we could think about just a monetary price for fruit and then the monetary price for bread. What's really important is the price ratio, the ratio at which fruit could be traded off for bread. And so in other words, it would be the slope of a budget line or a slope of a price line that would be relevant. And to get equilibrium in this model, to have an equilibrium, we're going to have the equilibrium price line is going to have the same slope as the budget, as the PPF and the indifference curve at point E, which is the tangency point. So the price line that we fit in here ends up giving us an equilibrium, and the slope would give us the relative price, the ratio of the price of fruit to the price of bread in this economy. And how can we see that this is a equilibrium in this economy? Well, if you're the producers of bread and fruit, if this is the slope of the if this is the prices that have been established in the market, and you're going to take those prices as given, think of different. You could evaluate different points on the production possibilities frontier in terms of how valuable they are. What is the value of the bread and the fruit that you produce? And if you produce a combination of bread and fruit that's more valuable, then at that price rate, given those prices, you would achieve more revenue. So if you want, one way to think about it is that at this slope of, if all of the different firms producing fruit and bread in this economy take these prices of fruit and bread as given, in order to take the price ratio as given, then what they are trying to do is think of what point along this production possibilities frontier would give them the most valuable output that they could get. And so you could think of taking a budget, taking a whole bunch of budget lines with this slope that I've drawn in here, and evaluating different points on, or I guess you also say inside the PPF. And if you, in the budget line that goes farthest out to the northeast would represent the most valuable combination of bread and fruit that you've identified. So what to maximize the value of production given the price ratio, you'd have to have a budget line that's tangent to the PPF, and that happens to be here. So from the production side of the economy, that's how we could see that we have an equilibrium, because producers are maximizing the value of their production. And then from the consumer standpoint, we can see that this price line is going to clear the market. So in other words, given this price ratio, and again, assuming that we have this like average consumer, so we're not worrying about different things. This average consumer, if they face the green budget line here as this green price line as a budget line, they would want to consume at point E along this budget line. So point E would be actually their utility maximizing point along this budget line that we've drawn in here. And that's really what we need to have for a full general equilibrium. It comes down to consumers have to be maximizing their utility, and producers have to be maximizing profit, which in this case here would be the market value of the bread and fruit that they could produce. And that turns out to be at point E as well, along with this price ratio. So the competitive equilibrium is the point plus the price ratio. And it turns out there that we've drawn both the efficient quantity and the equilibrium in here, and that's an important result known as the first theorem of welfare economics. And the slides and my notes from the chapter talk about that in some more detail. It's a really important result. It turns out that the way we've defined equilibrium and the way we define efficiency here are separate. On this diagram, we're seeing that they coincide, so it looks like they're sort of like the same thing. But they are defined differently, and they turn out to be the same. And that's what we talk a little bit more about in the book and in my notes and on the PowerPoints about the really important thing that we call the first welfare theorem. Okay, so that's general equilibrium in this production possibilities frontier model.